In this lesson, we're going to take our understanding of operations with rational numbers and we're going to do some application problems. I'm going to show you one example using each of the four operations. So in this first one, we're going to be using addition. Let's go ahead and read it. Jennifer has two pictures that she wants to put beside each other in a frame. One picture is 3.5 inches wide and the other is 5 1/8 inches wide. How wide must the frame be to fit both pictures? So you can kind of see what we're working with here and why we're using addition. If you kind of just draw a little picture here, we're going to have two pictures that are going to be side by side. And we're trying to find how wide these pictures are going to be once you place them side by side next to each other. And that will indicate how big our frame needs to be. So that's why we're using that operation addition. So let's go ahead and look at our numbers first. It says that one picture is 3 5/10 inches or 3.5 inches wide. So what I want to do with that number is, for the purposes of this example and showing you how to work with these rational numbers, I actually want to change it into a fraction. We know that the 0.5 on this number indicates that it's a half, right? So couldn't we rewrite 3.5 as 3.5, just like this? Yeah, they're equivalent rational numbers. Now the other one is going to be 5 1/8 inches wide. So I'm going to go ahead and write that here, 5 1/8 inches. And again, like we said, we're adding these two together. So in the last lesson, we talked about how to add rational numbers. What I'm going to do is I'm going to make both of these two numbers improper fractions. So let's go ahead and make the first number an improper fraction. What we're going to do is we're going to multiply our denominator 2. We're going to multiply it by 3, and we're going to add the numerator. So 2 times 3 is 6, plus 1 is 7, giving me 7/2. My second is going to be 8, my denominator, times my whole number 5, plus 1. So 8 times 5 is 40, plus 1 is going to be 41. And that's going to be over 8. Okay, now what we want to do is we want to add fractions here. Remember what we need to do when we add these fractions. We need to come up with a greatest common factor for our denominator to create our common denominator. So in our case here, our greatest common factor is 8. So I'm going to rewrite it just like this. And then I need to figure out what I need to multiply the numerators by. In the first fraction, I multiplied the 2. I multiplied it by 4 to get me to that 8. So I also need to multiply the numerator by 4. That's going to leave me with 28 in the numerator. In my second fraction, you can see that 8 remained the same. So I don't need to do anything with the numerator in my second fraction. Now, to finish off my fractions here, all I need to do is add my numerators. So that's going to leave me with 69/8. Okay, now we did talk about this. This is our final answer, and that looks kind of silly as a fraction, but that's okay. It's just a number. So how wide must the frame be to fit both pictures? Well, 69/8 inches, but that's also equivalent to the decimal of 8 625 thousandths. So the frame must be 8 625 thousandths inches. We'll say inches wide. So the frame needs to at least be that big in order to fit these two pictures that we have here. So I'm going to go ahead and box my answer. Okay, now that was an application problem using addition. Now let's go ahead and look at one that's using subtraction. Students in Computer Solutions have created two data files on the computer. One file is 2 1/9 megabytes, while the other file is 9/2 megabytes. How much larger is the second file than the first? Now I know this kind of seems silly because these numbers kind of seem wonky, but all they are just fractions, meaning they're not whole numbers, they're fractions of a number or fractions of a whole number. So let's go ahead and look at this. we're looking for how much larger the second is from the first. But let's go ahead and just kind of look at what the first is. It says one file is 2 1/9 megabytes. So that's going to be file 1. And then it says, well, the other file is 9/2 megabytes. That's going to be file 2. And we want to know how much larger the second file is than the first. So let's go ahead and take these numbers and let's go ahead and subtract the first file from the second file. So my second file is going to be 9/2. And from that, I'm going to subtract 2 1/9. And the reason I subtracted the 2 1/9 from the 9/2 is because I'm trying to figure out how much larger the second one is than the first. And that's the operation of subtraction. We're trying to find the difference between the two. So again, just reviewing our mixed numbers, we want to turn that into an improper fraction. So I'm going to keep 9/2 exactly the same, and I'm going to go ahead and work with the second one. So 9 times 2 will give us 18, plus 1 will give us 19. So I have 19 over 9. Okay, now I need a greatest common factor between the denominators 2 and 9, because that's how we subtract rational numbers. So looking at these two denominators, I can see that 2 does not go into 9 evenly, so I'm actually going to have to go a little bit bigger than 9. Our greatest common factor, which is going to be our common denominator in this case, is going to be 18. So let's go ahead and look at the 2. The 2 got to 18 by multiplying it by 9, because 2 times 9 is 18. Now we need to multiply the same thing. 9 times 9 is going to be 81 in my numerator of the first fraction. Okay, now going from 9 to 18, I multiplied it by 2. So I also need to multiply the numerator by 2 as well. So 19 times 2 is going to give me 38. Now that I have my common denominator, all I need to do is subtract my numerators. So that's going to leave me with 43 over 18. Okay, now that I have 43 over 18, I can see that is a simplified fraction. But let's go ahead and put it into a decimal using our calculators. 43 divided by 18, that's approximately 2, and I'm going to say, you can see that it's going to be about 3/8 repeated, or 2 38 hundredths repeated, but I'm just going to go ahead and I'm going to say that's about 2.4, just to make it easier for us. And all I did there was I rounded to the tenths place. So what this is saying is, the question asks, how much larger is the second file than the first? Well, it's 2.4 megabytes. Go ahead and label it larger. And we're done. Okay, now we've done an example of adding and subtracting, and now we're going to go ahead to multiplication. Grandma's recipe for chocolate chip cookies calls for 2.5 cups of flour. She only wants to make 75% of a regular batch of cookies. How much flour should she use? Okay, multiplication is coming into play here because we just want to make a part of a batch. We don't want to make the whole batch. So the whole batch is going to be 2.5 cups of flour. But she only wants to make 75% of that regular batch. So let's go ahead and figure this out. The chocolate chip cookies, the regular recipe goes for 2.5 cups of flour. What we're going to do is multiply it by the percentage of how much we actually want to make. We only want to make 75% of the batch. We know that 75%, if we were to create a decimal out of 75%, just as a little review, we would move the decimal 2 spaces to the left, which would give us 75 hundredths. And 75 hundredths is like 3/4, right? Isn't that 75 cents? Can't we also write that as 3/4? So basically, we're going to be multiplying it by 3/4. So now let's go ahead and change our first mixed number into that improper fraction. I'm going to multiply my denominator by the whole number. So 2 times 2 is 4. I'm going to add 1. So I'm going to get 5 over 2 times 3/4. And multiplication is my favorite because we're just going to multiply straight across. 5 times 3 in the numerator is going to leave us with 15. And 2 times 4 in the denominator is going to leave me with 8. All right, 15 over 8 is simplified fully. So this is going to be our final fraction. But if we want to write this as a decimal, we're going to go ahead and just divide them. And it's approximately 1 875 thousandths. So what does that mean? Well, how much flour should you use? So we should use about 1 875 thousandths of a cup, or 15/8 of a cup. Okay. Now, again, just to kind of review what that actually means is, 1 875 thousandths of a cup of flour. It's just basically saying you're not making the whole recipe. You just want to make 3/4 of the recipe. So we had to multiply 3/4 by the amount of flour that is going to be used in the entire recipe. That's called the percent of a number. All right, I have one more example here for you, and it's going to be division. Okay, 1 bag of potting soil from Home Depot contains 8 1/4 quarts of soil. How many clay pots can be filled from the bag of potting soil if each pot holds 75 hundredths of a quart? Okay, so now what we want to do is, you can see that we have a whole bag of potting soil from Home Depot. And they even give us the amount. So it contains 8 1/4 quarts of soil. All right, so that's like the whole bag. We're going to split that bag up into a bunch of little pots. And each of the pots holds just this tiny little amount, 75 hundredths of a quart. So what we want to do is divide the big bag by the little bag, or the little pots, to figure out how many pots we can actually fill. So we're going to be taking that big bag, which is 8 1/4 quarts, and we're going to be dividing it by how much each pot can hold. And that's going to be 0.75. Now, I don't want to write 0.75. 0.75 or 75 hundredths, again, can be written as 3/4, right? So I'm going to go ahead and write that as 3/4. Because if we think about that decimal, the decimal is equivalent to 75%, and it's also 3/4, right? 3/4 in a dollar makes 75 cents. All right, now that we have our rational numbers here, we have these nice fractions, let's go ahead and change our mixed number into an improper fraction. So we have 4 times 8 plus 1. That's going to leave us with 33 over 4. And I'm just going to rewrite it as divided by 3/4. Now, we need to do that little thing that we did in the last lesson. Do you remember this? Keep, change, flip. You always do keep, change, flip when you're working with division of rational numbers. So let's go ahead and keep 33 over 4. Let's change our operation division to multiplication, and let's flip our second fraction to 4/3. Now what we can do is we can multiply straight across. So 33 times 4 is going to leave us with 132, and then 4 times 3 is going to leave us with 12. And if we were to simplify this, it's actually going to simplify to a nice whole number. This is a great time to grab your calculator and divide 132 divided by 12. And you can see that that's going to leave us with a nice whole number of 11. Now, what does that mean? Well, if I go back and look at my question, it's asking how many clay pots can be filled from 1 bag of potting soil. Well, we had all the numbers, and when we plugged them all in and did the math, we can see that the big bag of potting soil is going to fill 11 pots. Okay, so that was a nice little review of just how to use those rational numbers within the operations, but also applying it to practical problems. Now, just as a refresher, I did change all of these numbers into fractions. But you can absolutely take these numbers and change them into decimals if you prefer. For example, I'll give you an example of that. If I take this 8 1/4 up at the top, I'm going to rewrite it right here. We know that 1/4 is let me write it right here. It's going to be 25 hundredths, right? Just the 1/4. If I were to write this number as a decimal, all I would need to do is write the whole number 8 right in front. So I could technically take my 8 and 25 hundredths, and I could go ahead and divide it by my 75 hundredths and get the exact same answer. But I kind of wanted to go the fraction route with you just to kind of show you that this is possible. Okay, that brings us to the end of our lesson of the applications of rational numbers.